So, in the last bit of a review, we talked about how the organization of the electrons in an atom could be represented with an orbital notation. A lot of times they're drawn like this, but they're also sometimes drawn where they don't, where they're more horizontal in their orientation. Again, this right here, these should all be squares with arrows up, one arrow up in each of these right here, would be the exact same thing as this right here. All right, but recall that what is more common to do is that instead of describing things using the orbital notations, we put them into what are called electron configurations. All right, and that's just a text way to describe this right here. All right, so for example, if you had these electrons in these orbitals, its configuration would be 1s2, 2s2, 2p3. All right. So the 1s means the s orbital, s sublevel in the first principal quantum number. All right. So that 1 right there is the n value. All right. And the exponent 2 means that there's 2 electrons in that level. All right. So that describes what you see up here, right? But when we get to more complicated, atoms that have more electrons, we start to get a little bit of overlap of the electrons, and you can see that a little bit in this slide right here, where there's no overlap in the energies between the first and the second, all right? But and there's no overlap between the third and the second. But there is overlap between the fourth and the third. All right, so there's this little way to memorize the order that you fill the atoms, and that is, to fill the orbitals, and that is using this thing called the diagonal rule. All right, and what the diagonal rule is, it's just a way to remember this order. All right, and using the diagonal rule, you first want to lay out things where you've got your S sublevels in this column, P here, D here, and F here. All right, and remember, you add an additional level up until you get to 4, and then you just start writing down things. All right, and then you're going to draw these diagonal arrows. And we can keep on going. All right, and remember, anything in a S level, it can hold 2, P level can hold 6, D level can hold 10, F level can hold 14. All right, and remember, when you say level, sometimes that's not the same as saying orbital. All right, so when the P level can hold 6, that's because it's got 3 orbitals, and each of them can hold 2. All right, so if we're going to do this for an element, let's do this for something fairly complicated. We'll choose antimony, which is has 51 electrons. All right, so I would start off here. I would go 1s2. All right, when we're done with going down that, we come up to the next arrow, and we just do it in the order that the arrows go. All right, so it would go, after that, it would be 2s2, 2p6, 3s2, 3p6. All right, notice after 3p, so with 3s2, 3p6, next would come 4s2. All right, after you're at the end of that, we go up to the top of the next arrow, 3d10. Then comes 4p6. Then after 4p6, remember we're following the arrow all the way down, 5s2. All right, let's see how many we've got so far. So that's 38 up to that point right there. So after 5s2, we go up to the top of the next arrow. Okay, so we're going to get 4d10. So that's 48. So remember, we're trying to get to 51. So we only need 3 more electrons. So after we fill up that 4d10, well, the next one can hold 6, but we only need 3. So we're just going to partially fill that next one. So 5p3, and that would get us to the 51. All right, so remember that there's that little trick to figure out whether it's correct or not by looking at the position on the periodic table. Antimony is right there on the periodic table. You can look at it on your own, but it should be in the P block, and it's in that third column of that. So it would make sense that it ends in P3. All right. So some questions about this. All right. What would the valence level be? All right. The valence level would be the 5th level, because if you look at the initial numbers in all of these, the highest one that you see anywhere is a 5. All right. So, but what would the valence electrons be? In this case, the valence electrons would actually be here and here. So I want to point that out. Notice that the valence electrons aren't necessarily going to be all grouped together. All right. Notice that there's these four 4d10 electrons that are actually between these in the configuration. All right. These are not valence electrons right here. These ones right here are. All right. So remember, trust this little part right here to give you the correct order, and then just look for the highest number that you see everywhere. All right. So if the question was how many valence electrons would there be, the answer would be 5, because you've got 2 here and you've got 3 here. 2 plus 3 is 5. Right? Right. One thing I want to remind you about are some details about how to answer your questions when it's about electron configurations. On the test, this type of a configuration would be asked to be entered in a format like this. Oops. Okay, so in order to prevent people from having to worry about doing the superscripting, you just type everything as if it's regular text. All right. Examples of that will be provided in the test, so just make sure that you're following the example, the format of how the examples are given there. All right. So you also want to make sure that if it asks for this type, for the regular electron configuration, you give it that way. But remember, we also have these things which are the noble gas configurations. All right, so this is the regular, but if it were to ask for either the, all right, so if it were to ask for either the noble gas or the condensed notation, all right, that would be the one where it asks you to remember that this part of the configuration right here, that part is actually the configuration for krypton. All right, that's the noble gas that comes before this. And so this entire configuration could be shortened to krypton with square brackets around it, and then you just write what comes after that, starting with 5s2, 4d10, 5p3. All right, so make sure that you're paying attention to what exactly the question is asking for. All right, and the last little bit is that I just want to point out, so we did nuclear reactions, and I covered nuclear reactions. I gave some slides on this, but I also created 2 solution videos. This is on my Canvas page. It's on the February 16th page. So please rewatch those if you want help in identifying those reactions. So remember, there's alpha decay, beta decay, there's fission, there's fusion, and you should be able to spot those different types of reactions if provided one. There's also the half-life problems, which are described right here. All right. So that is it for the review of this unit. Remember, anything that is part of this, the current unit that we've been talking about, will not be on the test. But if you review that material, you should be in good shape for the test. All right. Thanks, guys, and good luck.